And now, let's get started.
Basically, our facility, we've been open coming into our 6th year, and we've been working on really providing a place for startups to grow in this kind of robotics and electronics ecosystem. We know that it's a very hard thing to do, to be able to build robots, build any kind of product. And so we wanted to be able to have space for people to have that, as well as build a community of people so it's not all reinventing the wheel every time. So being able to collaborate, be able to understand the same problems that face all of our companies here. We have over about 70 companies here that are active and have raised over $18 million in the last 18 months. I'm sorry, $60 million in over the last 18 months, which has been a really exciting success story for us to see these companies grow and to blossom into this industry. The other part of our program is Mech Labs. Mech Labs is our educational program where it's a build it to learn it approach to understand and grow your skills in robotics. And we take everything from complete beginners all the way to industry professionals to understand how to reskill and grow their careers in this new industry of robotics.
Hey everyone, I'm here with Dan. He's gonna explain the Boston Dynamics Spot robot, okay? So let's take a look at it.
So this is the Boston Dynamics Spot, and this is with one of our companies, Merkelbot. They actually do developer training on this robot remotely. So a developer can actually come in and be able to control this incredible robot. It's a $70,000 industrial robot, and there are very few developers that work on this model. So that company actually helps people get trained on this piece of equipment. We also have a relationship with them that we can use it as a teaching tool for our Mech Labs program. So for example, we did a search and rescue program. So we were able to, about 1 week, we took intermediate Python developers and were able to have this robot autonomously navigate a obstacle course and then find a lost child and then report back on the location of that robot. And so this is just one of the fun projects and things here that makes Circuit Launch such an amazing place to work and to learn about robots from.
I don't know what they told you, but I just can't hold it in. And I don't know how I feel yet, cause I just done lost a friend. Stuck between I miss you and the shit is not real. Feelings very deep, I can't feel. So my question would be with the search and rescue mission that you guys did, you guys got your data and everything, are you guys gonna come back and work on, excelling it, getting better at it? What's kind of next steps as far as the robot?
Well, we'll be doing more programs like that. And the main idea is just to learn how to be able to interface and program on Boston Dynamics Spot, which is they're selling a lot of these to industries, and there's just not enough people who know how to program and maintain and to do the deeper level programming with these robots. And so that's the main thing. Everything for us is project based. The way we learn is we come up with a project, and for us the search and rescue project was a perfect implementation of learning to code on awesome hardware. So this is actually a robot. It's a little naked at the moment. It's normally got some covering, but Friendly Robots, which is one of the winners of the American Made Challenge, is one of our companies here, and they actually are working on industrial carpet cleaning robots. Kind of like your simple Roomba, except for much larger industrial spaces that can have a whole fleet to be able to do vacuuming of industrial carpets as well. Okay,
yep.
Go for it.
Go ahead.
So this is Ethereal. They create a motion simulator VR gym. So it's actually able to be in VR and be in the metaverse while actually getting a good workout. an awesome way to giant, basically fly a giant speeder or a mech or anything in virtual reality, and then be able to actually get a good workout. And that's their whole idea.
Okay, so who's the youngest people here? Who's the youngest group?
Well, we do programs all the way down to probably just middle to end of high school, all the way to advanced engineering. So we have a large age group. We don't tend to focus on kids. We're more for adults and high school, college graduates on. So this is our electronics lab here at Circuit Launch. We have several laser cutters. We actually have a full PCB, which is printed circuit board prototyping facility. So you can be able to mill out boards, for example, and actually see in copper, and then be able to build the whole board right here in about an hour. Between the mill and this, which is actually a printer, it actually will print out the traces, but it can also help assemble the board doing solder paste application and reflow. We also have, of course, several test benches. We have full capabilities with multimeters and DC power, soldering irons. This is a pick and place machine. This actually will place the components on a printed circuit board. And then, of course, we have a wide variety of capability and tools such as 3D printing. This is resin 3D printing, and that actually can go down to the resolution of about 25 microns, so very high resolution printing, lower volumes. We, of course, have a lot of other capabilities and other tools and equipment. This is our full rack of 3D printers. And you can see this is our more side of what most people know as their consumer grade 3D printer. They're called FDM, which just uses like the PLA plastic filament. And you can see here, for example, someone is printing out something which I have no idea what it is, but it's an exciting project, I'm sure. So controlling and learning robots is something that can be started very small and can go up to something very, very complicated. They're all basically working on, a small single board computer or a small microcontroller or even a small mini computer. And in general, most people start learning in Linux and start running the programs using Python and a variety of ways of programming these. But learning how to do this is no longer that challenging. There are so many tools and abilities to be able to learn basic programming, basic skills, and then build something for fairly cheaply. Like I said, this one is about $300 to get into building that. And this robot, for example, we built as a team with Mech Labs. This is Ricci. It is a open source project from France that our team was the first team to be able to build this outside of the developers, and they did it in 12 weeks, and total build cost for this robot was probably about $6,000. And the nice thing about Mech Labs is the program, they came in, learned this as a team. No one else had ever done this before, and so we all learned together by building this project. Some people were very beginners at it, other people had a lot of experience, but as a team we were able to solve, develop, and grow this robotics platform so that actually a lot of people could start using it and start learning robotics on it. So this is our biolab. This is actually a growth from one of our startups. They were needing lab services. They were in an expensive lab, and so we basically were able to build this lab because someone needed it. This is part of our business model is we want to say yes to the crazy ideas that startups have. And so we got into from electronics and hardware all the way into life sciences. So now people are able to come in and be able to actually rent a workbench and be able to do research and laboratory services all here on site. Everything from a biosafety cabinet to the -80 fridge and the basics that you need for a BSL-1 lab to be able to do research and grow your business even if you're just one researcher. This is our TARDIS. We actually designed and built this as a phone booth for our members to be able to take calls in our little spot. And yes, it's bigger on the inside.